Aviation is one of humanity's greatest achievements, yet most people never see the immense amount of engineering and craftsmanship hidden beneath the surface of every aircraft. We admire the wings, the engines, the sleek silhouettes cutting through the sky. But the real magic often lies in the parts we rarely talk about, the systems that help planes lift off, fly safely, and return to Earth without fail. To understand the brilliance behind modern flight, you have to step into the world of manufacturing plants, military overhaul facilities, precision labs, and engine test chambers where some of the most advanced technology on the planet is created, perfected, and maintained. Take Airbus, for example. Across Europe, the company has built a reputation for manufacturing safe and reliable commercial aircraft. But one of the biggest reasons they perform so well is their partnership with Safran, a global leader in landing gear and braking systems. Landing gear may look simple from the outside, but it carries enormous responsibility. At touchdown, a 200 to 300-ton aircraft slams onto the runway with massive force, and it's the landing gear that absorbs it. That level of stress demands a system that's incredibly strong yet lightweight, durable yet flexible, and engineered with microscopic precision. Safran's process begins long before any metal is cut. Teams of engineers create digital simulations and physical prototypes, analyzing how each part will perform under extreme conditions. Once they settle on a design, the manufacturing begins. Highly specialized machining tools cut metal components down to exact specifications measured in fractions of a millimeter. A single piece may go through heat treatment processes to strengthen it, protect it from corrosion, and increase its lifespan. After machining, parts are coated, painted, inspected, and tested before they ever reach assembly. Assembly itself is an art form, a blend of human skill and machine accuracy. Automated systems handle the repetitive tasks that must be flawless every time, while experienced technicians tackle delicate operations that require judgment and expertise. Only after the completed landing gear has passed a series of intense performance tests, stress simulations, hydraulic trials, load assessments, does it get approved for installation. On an aircraft like the A350, the attention to detail in every step underscores how vital landing gear is to aviation safety. Airbus also collaborates with companies like De Heer, a French manufacturer known for building smaller aircraft but equally skilled at producing critical components for larger jets. One of their specialties is landing gear doors, which must withstand aerodynamic forces, high-speed airflow, and constant opening and closing cycles. De Heer uses advanced robotics and computer-guided systems to shape and assemble these door panels. Robots excel at precision tasks, and in aerospace manufacturing, even a tiny error can compromise a component's performance. By incorporating automated systems alongside skilled technicians, De Heer ensures its components meet Airbus's exacting standards. Even with this level of engineering, no component lasts forever, which is why maintenance plays such a massive role in aviation. For commercial jets, regular inspections and scheduled overhauls keep aircraft safe for decades. But in the world of military aviation, maintenance is even more critical. The US Air Force and Navy operate aircraft that endure far more stress than commercial jets: rapid acceleration, short takeoffs, hard landings, high-G maneuvers, unpredictable environments, and, in some cases, combat conditions. Their landing gear systems must survive an entirely different set of demands, and to keep them reliable, they undergo routine and major overhauls at dedicated facilities. Hill Air Force Base in Utah is home to one of these vital operations. Here, a company known as Heavy Lifter Assemblies manages landing gear overhauls for nearly every major aircraft in the Air Force fleet. It's a staggering list: the F-16, F-15, A-10, C-17, C-130, B-1, B-2, C-5, and even the F-35. They are the only organization trusted to perform landing gear overhauls for all Air Force weapon systems. An overhaul takes place roughly every 6 to 10 years, depending on the aircraft and how it's used. During the overhaul, the landing gear is completely dismantled, sometimes involving more than 2,000 individual parts. Each piece is cleaned, inspected, documented, repaired, or replaced. The level of detail required is extraordinary. A crack the size of a human hair could compromise the system, so technicians use specialized tools, magnification equipment, and measurement instruments to catch even the smallest imperfections. After the overhaul is complete, the gear is reassembled, tested, and certified before returning to service. North of Hill Air Force Base lies another powerhouse of aviation maintenance, the 532nd Commodities Maintenance Squadron. This unit is known as the Air Force's Center of Excellence for landing gear, wheels, brakes, and related systems. While Heavy Lifter handles routine overhauls, the 532nd specializes in restoring unserviceable or damaged gear to a like-new state. The process begins with a careful and controlled disassembly, followed by an initial inspection to determine what can be repaired and what requires replacement. Parts are then sent through cleaning processes that include chemical stripping, blasting, and degreasing. After cleaning, components undergo multiple rounds of inspection, such as fluorescent dye penetrant testing, which highlights microscopic cracks invisible to the naked eye. Mechanical integrity tests assess whether the parts can withstand the stresses of flight. Those that pass inspection are replated, ground, painted, and forwarded for reassembly. Those that fail are rebuilt or replaced entirely. Every step of the process is documented, ensuring a complete maintenance record that tracks each component's entire service life, while landing gear is a marvel of engineering. Nothing compares to the complexity of a jet engine. These machines are the beating heart of an aircraft, generating the thrust needed to propel jets through the sky at incredible speeds. A modern jet engine contains thousands of parts arranged in precise order. The air intake, compressor stages, combustion chamber, turbine assemblies, and exhaust system all must work in perfect harmony. Temperatures inside a jet engine can exceed the melting point of many metals, and rotating components spin at tens of thousands of revolutions per minute. In military environments, engines endure even more strain, afterburners, rapid throttle changes, extreme altitudes, and heavy loads. Because of this, engines undergo regular inspections and deep maintenance about every 3,000 flight cycles. The process begins with removing the engine from the aircraft. Technicians detach external hardware, disconnect fuel lines, electrical systems, and hydraulic connections, then separate the engine from the airframe. A specialized transport cart supports the engine during removal and carries it to the maintenance bay. Once inside, experts study the engine's service history, temperature readings, vibration reports, fuel efficiency measurements, and any irregularities logged by pilots or onboard systems. The next phase is disassembly, where the engine is broken down into its main components. Parts are divided into static elements that don't move and rotating components that experience constant wear. Each piece is cleaned to remove grime, carbon buildup, and residue from combustion. After cleaning, technicians inspect every surface, every blade, every seal. Some inspections require microscopes, others use ultrasonic testing or advanced imaging. Components that are worn or damaged are repaired when possible or replaced when necessary. Once the engine has been cleaned, repaired, and reassembled, it must be tested before returning to an aircraft. That's where the Hush House comes in, a massive, sound-suppressed hangar built to handle the thunderous roar of a jet engine at full power. Inside these facilities, engines are mounted to thrust stands that hold them in place. Technicians run the engine through various power settings, from idle to maximum thrust, monitoring temperatures, vibrations, airflow, and fuel performance. The Hush House allows this extreme testing to happen safely while minimizing noise that would otherwise shake the surrounding area. Only after an engine passes all tests is it cleared for installation on a mission-ready aircraft. When you take a step back and look at everything that goes into maintaining aviation, commercial or military, it becomes clear that modern flight is far more complex than most people realize. From landing gear assemblies built with microscopic precision to engines capable of producing thousands of pounds of thrust, every system demands constant care. The aircraft we trust for travel and national defense rely on the millions of hours spent by engineers, technicians, machinists, and inspectors who work behind the scenes. Their dedication makes air travel possible, predictable, and astonishingly safe. And while these systems may be hidden from passengers and even pilots, they represent some of the most advanced and reliable engineering on Earth. Every flight that takes off and every aircraft that returns home is a testament to the people who build, maintain, and perfect the technology that keeps modern aviation soaring.